Somewhere in the constellation Sculptor, a faint patch of southern sky with no bright stars of its own to draw attention, there's a planet shaped like a lemon, orbiting the crushed corpse of a star that used to be much bigger than our own sun. Its atmosphere is made of something that, chemically, almost shouldn't be able to exist. And deep inside it, scientists think there might be rain made of diamonds. This isn't science fiction. It's a real object, catalogued as PSR J2322-2650b, first noted to exist back in 2017. Though its bizarre atmosphere wasn't fully studied until much more recently. The astronomers who finally analyzed the data in detail described their own reaction in 3 words. What the heck? The planet orbits something called a millisecond pulsar, the collapsed core of a massive star that died in a supernova, then kept spinning at an almost unbelievable rate. This particular pulsar spins roughly 700 times every single second. Physicist Michael Zhang, of the University of Chicago and the lead investigator on the study, described the host star simply. It has the mass of our sun, packed into something the size of a city. Technically, this system is classified as a black widow pulsar, a name astronomers use for a pulsar that is slowly eroding and consuming a smaller companion object with its own radiation. Similar to how a black widow spider is named for consuming its mate. Astronomers have identified other black widow systems before, typically involving a pulsar and a companion star being gradually stripped of its outer layers. But a companion that's already this planet-like, with an atmosphere this exotic, is new territory even within that already unusual category. It's a category that was already unsettling before anyone knew what this particular planet's atmosphere actually contained. The planet itself is roughly the mass of Jupiter, and it orbits this dead star at a distance of only about 1 million miles, barely 1% of the distance between Earth and our own sun. At that range, it completes a full orbit in just under 8 hours. Being that close to a pulsar comes with consequences. The immense gravity of the collapsed star is physically distorting the planet, stretching it away from a sphere into something closer to an ellipsoid, a shape astronomers have compared, half-jokingly, to a lemon or a football. This isn't guesswork. The shape was calculated by modeling how the planet's brightness changed throughout its orbit. Work led in part by Maya Belesne, a graduate student at Stanford University. Here's where it gets genuinely strange. Using NASA's James Webb Space Telescope, the research team, including planetary scientist Peter Gao of the Carnegie Earth and Planets Laboratory, analyzed the planet's atmosphere directly. What they found didn't match any known category of exoplanet atmosphere. Instead of the water, methane, or carbon dioxide astronomers typically expect, the data showed something almost nobody anticipated. An atmosphere dominated by helium and unusual carbon molecules called C3 and C2, molecular carbon chains that almost never survive intact in a typical planetary atmosphere, because carbon usually bonds instead with oxygen, hydrogen, or nitrogen. The near-total absence of those more common elements is itself a mystery the team is still working to explain. Zhang noted that this represents a genuinely new category of planetary atmosphere, one nobody had previously observed or fully predicted from theory. Under the right conditions, this exotic carbon chemistry could allow soot-like clouds to form. And deep within the planet, that same carbon may compress into solid crystals. In other words, diamonds forming naturally inside a planet's atmosphere and interior. As a byproduct of chemistry, nobody expected to find there at all. The planet's atmosphere is also blisteringly hot, reaching around 1900 Kelvin. or roughly 1630 degrees Celsius, far hotter than it should be from starlight alone. Ordinary starlight at that distance would only produce around 1300 Kelvin. The extra heat appears to come from the pulsar's gamma radiation, constantly battering the planet's day side. Strangely, the atmosphere itself circulates in the opposite direction to the planet's own rotation, sweeping westward while the planet, tidally locked to its orbit, spins eastward. There's an unusual advantage buried in how astronomers were even able to study this system so precisely. Most exoplanets are enormously difficult to observe directly, because their host stars are millions of times brighter, completely washing out any light coming from the planet itself. That's why the overwhelming majority of confirmed exoplanets have never actually been seen directly at all. They're detected indirectly, through the way they dim their star's light or tug on it gravitationally, not by capturing the planet's own glow. This particular pulsar mostly emits gamma rays and other high-energy radiation, wavelengths the James Webb Space Telescope's infrared instruments essentially can't detect. That means Webb can observe the planet's own glow in exceptional detail, across its entire orbit, without the star's light interfering at all, an observational trick that made this level of atmospheric detail possible in the first place, on a planet that would otherwise have been just as hidden as any other. None of this answers the deepest question the researchers are still sitting with. How does a planet like this even come to exist in the first place? Pulsars are born from supernovae, the catastrophic explosive death of a massive star, and that kind of explosion should, by any reasonable expectation, destroy any planet that happened to be orbiting nearby beforehand, vaporizing it or flinging it out of the system entirely in the blast. By the researchers' own admission, this is genuinely hard to explain. The extremely carbon-enriched atmosphere doesn't fit comfortably into any existing model of how a planet, whether original or somehow later, ends up in this state. The honest, current answer is that nobody has a confirmed explanation yet. And yet here it is. There's some precedent buried in the history of exoplanet science that makes this a little less unprecedented. The very first exoplanets ever confirmed, back in 1992, nicknamed Poltergeist and Phobter, also orbited a pulsar. It's a strange pattern. Some of the earliest, and now some of the strangest planets we've ever found weren't quiet worlds around stable stars like our own, but survivors, or perhaps latecomers, clinging to the remains of stars that already died violently. Among the thousands of exoplanets confirmed so far, this makes PSR J2322-2650b something genuinely singular. The only known hot Jupiter-type world, a large, gas-dominated planet locked into an extremely close, scorching orbit, found circling a pulsar rather than a normal, still-living star. Every other hot Jupiter astronomers have cataloged orbits a star, still generating light through nuclear fusion. This one orbits the leftover core of a star that already finished dying. Scientists studying material around the system have also found evidence that matter is actively being pulled from the planet toward the pulsar. Peter Gao described it in strikingly physical terms. There's a literal point on the planet, almost like a tip, where material actually streams off the surface and spirals inward toward its dead stellar companion. Whatever this planet is, it isn't simply sitting quietly in orbit. It's slowly being consumed by the very star that may have distorted its shape into that impossible lemon curve in the first place, in a slow-motion process that will likely end, eventually, with the planet's total destruction. Somewhere out there, in a solar system that shouldn't have survived the death of its star, there's a planet raining diamonds into an atmosphere no chemist would have predicted. being pulled apart by gravity strong enough to bend its entire shape. And the honest answer from the people who study it professionally is still, nobody fully knows how it got there, or how much longer it has before the pulsar finishes what it started. For now, it remains one entry in a much longer list of worlds that simply refuse to behave the way our models expect them to. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe because next time we go beyond again.